Hello everyone, this is Bowen. It's a great honor to be here to present our work in PMD conference. I'm from Newcastle University, and our project is focused on condition monitoring of price pack IGBT devices using deformation detection approach. So these are the two types of price pack. One is the conventional price pack IGBT, the other one is called stack pack, which has spring inside to balance the pressure. As the stack pack type has patent protection by ABB company, so my project mostly focuses on the conventional type price pack. As can be seen in the right side, this is a exploded view drawing of the conventional price pack IGBT. The classical price pack structure, which is based on the construction principle, generally it can be defined as 5 layers, which consist of two molybdenum plates, two metal leads, and a die in the middle. Each side of the die connects a metal lead via molybdenum plate in order to supply the thermal and the electrical contact. The gate distribution board is connected to the die through a spring-loaded pin, and the entire construction is placed in a hermetically capsule. As can be seen from these two figures, these are the model bought from Toshiba, and there are several advantages of price pack IGBT, such as no bond wire and solder layer, and it's easy to double-side cooling, and has short-circuit failure mode for this rigid type price pack. Also, it can continue operate normal for several hours after the short circuit, and these are especially suited for serious connection. From the right side figures, these are the applications using price-pack IGBT, such as the wind generation, the high-speed train, and electric vehicles. Also, the HVDC applications. So this slide, I'm gonna demonstrate the monitoring principle of price-pack IGBT. Although the price-pack IGBT has more compact structure comparing with the conventional IGBT module, the reliability of the device still need to be concerned. And this table shows the classical failure mechanisms of price-pack IGBT, such as the gate oxide damage, burnout, fretting, friction, or the collector lead groove expand. The unique failure mode is the uneven pressure distribution caused by the difference in clamping force or mismatch in CT comparing with the conventional IGBT module. And the right side figure shows the typical failed price pack IGBT, such as the chip damage and crack on the chip surface and the distortion of the collector lead. And more or less, this failure can lead to some deformation on the collector lead. And as mentioned in the previous slide, um, uh, the failure can lead to some deformation on the collector lead. Therefore, for validation of taking the deformation as the indicator of the condition of the device, the relationship between the deformation and temperature is investigated. The thermal conductivity of metal shows the feasibility of monitoring the device with deformation. From the formula, the strain occurs with the accumulation of heat quantity, which means when the lead groove reaches this temperature, the strain already here. And in order to investigate how much of the deformation generated by the device, the FE simulation is carried out in the following slide. And this slide gives more clear relationship among the main generated field inside the price pack IGBT. As can be seen from the figure, the coupled mechanical, electrical, and thermal field combine together and makes a contribution to the upper lead deformation. And there's a hypothesis that the uneven pressure distribution occurs caused by the deformation of the lead when the press pack housing heated. Therefore, the detection of the deformation is valuable, and the next section will demonstrate the simulation validation. So for finding out the parameter symbolize the condition of the device, we run the FE simulation in ANSYS workbench, and the left side figure shows the geometry model used in simulation based on the board IGBT, and all the components are included except the gate board and the plastic frame, which can be ignored in the deformation analysis. And the right side figure shows the total deformation of the upper lid, which illustrates that the maximum point is around the groove. And I used the static thermal and the structural statical simulation to get this result. So for analyze the deformation in detail based on the real environment, this slide shows the simulation verification of the previous hypothesis. I assume that the different temperature distribution represents different conditions of price spike IGBT. Since the normal operation temperature of IGBT chips ranges from 25 degree to 125 degree, so I set uneven power losses of IGBT chips and dies to get different temperature files, and then I transfer these files to the structure analysis. Uh, as, as can be seen, the figures shows that the axis deformation of the groove and the temperature of the chip fails. So with I increase the temperature of the chip, and then I get the increasing deformation of the groove. So I set the temperature 5 of the chip ranges from 93 degree to 167 degree, and then get the z-axis deformation of the groove ranges from 38 micrometers to 72 micrometers. And this slide shows the different parameters relationship. The left side figure shows that the relationship between the maximum temperature of IGBT and the maximum deformation along with the z-axis of the lead groove. As can be seen, with the temperature increase, the z-axis deformation increase. And the right side figure shows that the relationship between the clamping force and the deformation along with the axis of the lead groove. As can be seen, there's also a linear relationship with the clamping force increase, the deformation along with the axis also increase. But as can be seen from both the figure, it clearly shows that the thermal effect makes the more contribution to the lead groove deformation. So our next step is focus on to find the suitable sensor to detect this indicator of the device. So this are some available deformation sensors on the market, and for detecting the macro range deformation of the price pack IGBT, there are several conditions need to be considered. Firstly, the price pack IGBT are typical power devices for HVDC and new energy grid, which means series connected between price pack cell is necessary to achieve the high voltage ability. Therefore, only tiny space exists between IGBT and heatsink due to their unique package. In addition, the press pack IGBT normally operates under the high current condition, which shows that the high immunity to electromagnetic interference is needed, or decoupling measurement is necessary. Finally, the deformation measurement ranges from several micrometers to tens of micrometers, which require high measuring accuracy of the sensors. And based on the table, I select several sensors for the further investigation and propose two different sensors in this presentation. The first one is the string guard sensor, and the sensitivity of string guards is enough and has possible solution to reduce the size to embedded sensor on the surface of the lead. And the basic mirror circuit is to using the Wheatstone bridge, and I simulate the output voltage ratio, changing ratio based on the deformation variation. But the problem is that based on the market products, manufacturer tolerance cannot meet the need based on the simulation. And this slide shows another proposed FPG sensor. The basic idea is to attach the fiber on the surface of the groove, and the basic principle of FPG is shown above, as can be seen from the figure. And the laser injected into the fiber and goes through the sensing part lambda 1, lambda 2, lambda 3, and with the external environment change, it stretches the fiber and causes the grating part distance change, and then cause the output wavelength change. Therefore, the wavelength shift is related to the strain and temperature. And based on the left side formula, we can calculate the strain and temperature with the sensitivity. So according to the idea of using FPG sensor, it clearly meets the need of based on the condition of sensor selection. Therefore, the initial test is carried out by using the FPG sensor. This slide shows the test equipment and the specification of the equipment. So the above one is the tunable laser source, which can generate different wavelengths laser into the fiber. And the below one is the optical spectrum analyzer. It can read the output wavelength shift. So based on this table, it shows the specification and such as the wavelength accuracy, the wavelength resolution. It clearly shows that we can detect the micrometer range deformation. And this is the test result, as can be seen from the left side figure. I set different temperature, 50 degree and 100 degree, and I choose the FPG sensor with the central wavelength and 1542 nanometers, and it shows there's a wavelength shift with the temperature change, and to get a better understand of the wavelength change, I use the software to generate this figure on the right side. You can see the clear shift of the wavelength shift and the different temperature. Okay, so finally, based on the previous demonstration, we conclude that the deformation of the groove in the lead of the price pack IGBT was identified as the new condition monitoring parameter. And a study on the possible detection methods for the deformation measurement reviewed, and it is concluded that the FPG sensor is the most appropriate sensor to detect the micrometer range deformation. And the initial experiment shows that the promising of using this method. Thank you.